Welcome to this short video about how to use in the most effective way TBC with UASMaster. When you work anyway with Trimble Business Center and UASMaster, we would recommend to set up the project in TBC, because then this project definition can be used also in UASMaster. You can then just send the project file to UASMaster, and then you work in the same coordinate system engine that TBC uses. So therefore there is no problem then bringing back the data into the designed coordinate system that you use for your further processing in TBC. So I set up here a project which is 48 South, and then we continue. Okay, here we go. You can define any coordinate system you want in TBC. In this case here, it's 48 South for me. And then you send the project to UASMaster, which includes, in this case, our coordinate system itself. I will use here, if I have different versions installed, the current 10.1 version. There's very soon also 11.0 coming out. So you could also additionally install on your computer UASMaster 11.0 if you have a license for this. And then you could also export it to 11.0, which would be interesting concerning True-Orthophoto generation. This is then here also now possible. And then we could bring back the Mosaiks.tif, which would then be a True-Orthophoto. So I will stick here with 10.1 because this is what currently is included in the upcoming TBC version 5.4. And therefore let's select this one here. You could even already here import your ground control points, of course, here in TBC. If you would import your ground control points, then you would of course need to select them. In my case, I just now export the coordinate system. And then UASMaster opens up with the definition of my project type. I will use here, in my case, an area mapping project type and define my name. When we take a look at the project editor, we see now that the coordinate system is now here set. And this is then the coordinate system coming from TBC. And then we can just run the standard processing in UASMaster, import our images, import our ground control points, running georeferencing and Pointcloud and orthophoto generation. I want here to show mainly about generating orthophoto production and the different, for the Pointcloud generation, the different resolutions. So I will just skip forward and then we will take a look at how to define our resolution in the Pointcloud and our resolution in the orthophotos. Okay, so as the topic is about Pointcloud generation and orthophoto generation, we should mention at least the radiometric optimization. The radiometric optimization is a very nice tool in UASMaster. It will use the tie points, and through the tie point information we know from different photos the same location, because the tie point is the same location in different images. Then we can use from this location the radiometric information of the photo and we can make a radiometric homogenization of the images from our complete block. So what happens in the background is that we are creating metadata files that make our images brighter, darker, more intensive, intensity changes, color changes to the photos to each other, so that in the end they are looking more homogeneous, so that we have no differences so strong afterwards in our AutoMosaic final product. And also the Pointcloud itself will benefit from it. So that's for if your images have strong radiometric differences to each other, this would be also a helpful tool to make your mosaic look better at the end. Then we go into the surface and auto generation, and then let's start with the surface generation. In the surface generation, we can generate our Pointcloud based on different model types. So there is the LSM-FBM method, which is a terrain extraction method, which the main goal is when you have open terrain and you want to generate a more coarse point cloud, and which is very fast, and then you can use this one. CBM is already pixel-based matching. It's here when you don't have buildings included. It's more like mines where you have here extreme height changes and you want to model a very dense point cloud every third pixel, for example, then to calculate volumes and also to include all small details, but not so much man-made stuff like buildings or constructions. And then if you have construction and buildings, then the semi-global matching is the best choice. It's the taking most time of the production, but it also the most detailed ones, and it enhances the building rooftops in a very nice way, and therefore it's a very good tool also for the True-Orthophoto generation, which we can then also take a look later on. The resolution that you define through it is explained in the manual, so I just skip to this part here. So in the manual you see a chapter called 4.212 Generate Point Cloud. I think it's, if I go to the larger over heading, it's here the 421 Point Cloud Manager in the UASMaster aerial mapping part. And here we can see now there is for the point cloud generation these different types, the model types. And when we choose the LSM FBM, then the resolution is depending from our extraction level. So we have the extraction levels high, medium, and low. And if you would choose here LSM FBM and you would select here one of these three extraction levels, then this would be your result. That means if I take low, then it's the GSD, so my ground sample distance of my project. So in my case, I think it's 2 centimeter ground sample distance. And then these 2 centimeters are multiplied by 25. This is the grid size. And then because it's the low pyramid level, so it's factor 4. So that means in my case 4 times 25, so 100 times 2 centimeter. So in my case here, this would be a 2 meter grid. And if I take a medium, then this would then run on the first pyramid level. So also from the height accuracy, this is a difference. So here we run on pyramid level 2. Here we run on pyramid level 1, and also our output would then be 50 centimeter, and here it would be in this case, 1 meter, and here it would be 50 centimeter on high, and it would also run on the pyramid level 0. So that would be also the most accurate resolution from a height perspective. So this will be the 2 resolutions. So it's always depending from your GSD. So, and this is then the factors that you get. Then when we go to the next one, which is then the CBM, which is a pixel-based matching, we also again have here these extraction levels, but now we don't have the factor 25, but we will have now the factor 3, so every third pixel. And here on this part is when we take high, then it will run here on the original image. So 2 centimeter GSD would be in this case here the case. Then times 3, so 6 centimeters, and then pyramid level 2, so 4 times larger. So in this case here, this would be 24 centimeters. And here it would be 2 centimeters, 2 mal 3, 6, so 12 centimeter. And here 2 mal 3, 6 centimeters. Yeah. So this would then be the distance. And also again, height wise, it's a different pyramid level. So also the height accuracy would be different from these 3 setups. And then we have finally the CBM. I will not go into the SGM. I will not go into 3D because I would strongly recommend to run the 2.5D for area mapping cases. And here again, we have these 3 levels. Here it's a little bit different. For the SGM, the extraction, let me just be sure. And here it's different. So here in the SGM, we are matching every pixel, but the pyramid levels are different. So if we take high, then we will run this on the first pyramid level. So that means not 2 centimeter, but 4 centimeter resolution, but every pixel. So that means high would be every 4 centimeter spacing. Medium would then be twice 8 centimeter, and low would then be 16 centimeters. And the accuracy is then taken from first pyramid level, second pyramid level, and third pyramid level. So that means, just to say here, so high on the first pyramid level, medium on the second, low on the third, but every pixel, not every third like in the CBM. So this is how the resolution and the height accuracy is determined in the surface generation in UASMaster. Each of the point clouds allows to generate also the orthophoto. So when you run terrain, LSM, FBM, you can afterwards create orthophotos. When you run CBM, you can generate orthophotos. With the SGM 2.5D, there is a TrueOrthophoto generated automatically in the 10.1 version. So you will see a folder where the TrueOrthophotos are stored. And there's a slight difference also to version 11, where in this version 11, the TrueOrthophoto will then also be again our standard Mosaik.tif in the project folder. In 10.1, this is not the case. This is a separate folder. So I will show now the 2 different scenarios. I will use for speed issues the LSM now to generate the classic orthophoto, which is a Mosaik.tif. This would be the same if I would run CBM, but it's just taking longer time. And then I will run a second process with the SGM 2.5D, showing you how the orthophoto is then created into the this TrueOrthophoto folder. And then we will show how you can then bring in these orthophotos to Trimble Business Center back. And that's the main goal. So let's start with the first one, which is the LSM FBM run. And here we will then just run it on the lowest one. I just want to speed this here that we don't have to wait this long. It's more like showing what is possible. And therefore I start the process, and then we will take a look at the orthophoto quickly. We will generate the orthophoto from this quickly, and then we will then bring it back to TBC. Okay, here we go. This is our point cloud. I will not go into it. I just start now from this point cloud the orthophoto generation. This point cloud is our reference. So this is where this model is used to do the orthophoto generation. And therefore we will create here the classic orthophoto. In the classic orthophoto generation, we don't need to have a terrain model that has for every pixel a point. Therefore, we can here generate still a very detailed orthophoto, because the terrain model is only there to use the correct height selection, but the original images are taken then for the auto rectification, and therefore we will create now here a very accurate classic orthophoto. That means even with a very sparse terrain model, we can generate a very accurate classic orthophoto on a high resolution. Of course, the pixel size should not below our ground sample distance. I will generate here 5 cm classic orthophotos and then hit start and then define which points are considered and say OK. And now after I close the text file, my process starts, and then we wait till it's finished and then we take a look at the result. Okay, here we go. Our orthophoto is done. Let's take a look at the output folder. Here we go. So we have here our mosaic.tiff. This is our TIFF file that we will then bring back to TBC. And this is very simple. We can just here close the Pointcloud manager and then use then from the UASMaster sent to. One thing perhaps to know, it's also possible in the Pointcloud here to export to Acognition, and then our mosaic would be written into a GeoTIFF format additionally. So perhaps let's do this here. So we can here export the ortho mosaic, and we could also generate our terrain model. So let's make perhaps both. And then we can here in the output here then define our I think we cannot change, it's always a GeoTIFF correctly, but the terrain model can be then written as a raster GeoTIFF format, just to be aware. So let's here use this here, and for the raster GeoTIFF we can define a grid size. I will just make it here equal to 5, so it would be then interpolated into this one here, and then we can output this here. And this is generated into a separate folder. It's called Acognition Data. And then we have here both, so the GeoTIFF raster, and then again this orthophoto additionally also. Just to be aware, this is also possible. Then let's here exit here. And then in the applications master, we can now say here to send to, and we will send now Pointcloud and the ortho mosaic. We can also send the ground control points and make them to survey quality. This is possible. We will not export the DEM additionally. And then we say next, and because Trimble Business Center is open here in my background, it would then use the current coordinate system of this one. If TBC is not open, then the dialog would now ask to open TBC. You would need then to open the coordinate system, the project with the correct coordinate system, because we will now transfer into this current TBC, or if there's no current TBC, then you open a TBC project, and then it will be importing it to the current project TBC. And then we say next. Then there's some preparation done. Then after the preparation is done, then TBC is getting the information that we await an import. Then we can say yes, we want to accept this import, and then it starts to get the data into TBC itself. And then when the import is done, then we also get the finish dialog that the import has completed. So let's take a look or wait till this happens. So here we go. It's now finished. And now we can take a look and we see now here both included. So we have here our Pointcloud, and we have our, so let's take here the points out, and we also have here our mosaic. Yeah, so both of them are imported here. Okay, good. So this is about the orthophoto generation based on the FBM. It would be on the CBM similar. In the CBM, we would have here better building reconstructions. I will go back to UASMaster. I go back to the surface and auto generation. I will here now delete my point cloud. So I say here delete all points. Yes. So this is now done. And then let me here just make this larger. And let's just now run the SGM 2.5D. So we will select here SGM 2.5D. I will also run here extraction level low just to get quickly to our result. And then we will hit the start button and then wait for the result, and then we take a look to it. So now our processing has finished with the True-Orthophoto generation, and we can now see here the point cloud, which is colorized. Let's take a look also into the output folder, much more important. We see now here the Pointcloud file, but not the mosaic.tif file, but we see now in this case here an TrueOrtho folder. And in this TrueOrthophoto, we have now here our TrueOrthophoto generation from the SGM process, and they are multiple files here existing here, and they are all georeferenced. They also have a TFW file, and then you can here easily import them also into TBC, but not with the send to function. You would just need to directly in TBC add them to your project. So we will add a point cloud to TBC. So we can here go again into the UASMaster. And in the UASMaster, we can then here send to. We don't have the auto mosaic as mentioned, but the point cloud. And then we can send this here now to TBC. Say send to. TBC is awaiting the data. We say yes, get the data, and then when the preparation is done and the import has happened, then it's finished and done, and then we have here now the point cloud in TBC included, and we can then add now our orthophotos, and I would just drag and drop them here directly into my plane view, and then the TrueOrthophotos are loaded into TBC. So the TFW file is not used, but a TIFF file. We will now here just blend out our point cloud. And this is our TrueOrthophoto. But I think you see then now here the difference. So now here there is no building here cut off, and also here the edge is correctly then showing us the potential of the TrueOrthophoto, and therefore seeing the product quality of the TrueOrthophoto, which can be then imported into TBC. We hope you liked it, and it shows you the potentials of generating point clouds and mosaics with TBC and UASMaster. Have a nice day. Goodbye.